which resolution?
Yeah, go for the 1400 rated by 1050 euros. Okay, so the amount of system on that screen.
Too slow.
Okay. Super Mario. Absolutely.
Okay.
Just need to speak because you're probably 30 minutes, which means 20 minutes to talk. I can ask a question which on your side. Okay, for your progress. Right, good luck.
Okay, so let's get started. And please welcome Michael Bright.
Okay. So hi, I'm Michael Bright from HP. I work for HP in Grenoble, France. Can you hear me okay, by the way? No? Yeah. Is there a problem? Is that better? Okay. So I work in Grenoble, France, in our EMEA OpenNFV lab. That's what I do daytime, but otherwise I'm containers, unikernels. Okay. Okay. So I'll talk to you about what are unikernels, why we need them, in what domains they might be applied to, about the different unikernel implementations, about containers and unikernels. I think that's particularly interesting. I'll give a short demo, very short, and then some conclusions. Okay. So why this talk? Well, it's a hot topic, and I'm sure a few of you have seen a mention of unikernels this morning. I was expecting to have to wear a Kevlar suit, but I think you're a friendly crowd. Okay, so I'd like to talk about what we can expect to see from unikernels. I think it's a domain that's moving quite quickly now, and in particular, what I think Docker will be doing in that space, and who the different players are. So first of all, don't forget unikernels have actually existed since the 1990s. So there were exokernel and Nemesis projects from the 90s. Nemesis being from the University of Cambridge in the UK, and they're continuing to do a lot of work in this domain. Back in 2014, so I skipped forward a bit, there was a sort of seminal paper on unikernels published by ACM. And then in 2015, we were already in container mania. I was anyway. And then we started to see articles like this one, 7 unikernel projects to take on Docker in 2015. So I started to wonder what this was all about. And at the end of 2015, at DockerCon Europe, there are a couple of guys from unikernel systems, Mirage OS, Zen project, who did a cool hack at the end of DockerCon. And then in January 2016, Docker bought unikernel systems, so everyone wondered what's happening here. Actually, back in early 2016 already, there were a bit of reaction to the fact that Docker were buying unikernel systems, people wondering if this was really feasible. And since then, we've seen other people come back in defense. Okay, the other thing is 2017, I think we'll see some important developments like the third release of Mirage OS, which I'll talk about. And I kind of expect some announcements from Docker this year. So what are unikernels? So unikernels or library OS, the idea is that you build up an application including essentially the OS elements that you need. And so you build a static binary application that doesn't need an OS to run. It runs either directly on bare metal or, much more typically, on a hypervisor. Okay, and something quite specific about unikernels. So I've written there single process applications. Actually, that depends. There are probably at least 15, 20 unikernel systems that exist. So they're not all the same base. But in their more purest state, a unikernel application is a single process application. It's single user. It's single address space. So there's no context. There's no concept of kernel and user address spaces. They're very small size because you select only the bits of an operating system that you need. And they're very fast to boot, hundreds of milliseconds typically. They have a small attack surface because they have a small number of lines of code. I mean, to give an idea, the Linux kernel itself, not the distribution, but the kernel, has about 25 million lines of code. Of course, you only compile a fraction of that when you build because of your configuration options, but still it's enormous. So unikernels use a much smaller base because they pick and choose from the OS itself. And potentially that will lead to greater security, or at least source code will be easier to manage. It will be easier for one person to know what is in his application. There's potential for higher performance, for example, because there are no context switches going on within your process. But there's no shell, because we're talking about a single process. So you might worry, well, how am I going to debug this thing? Well, you debug in the same way that you would tend to debug an embedded application or an Android phone and so on. You'd have some other machine tethered to your device. So why they're needed? Well, you think for a moment about what OS you're running, probably Linux, but and on what hardware. In fact, you're running a generalized operating system on probably diverse hardware. So the Linux kernel or other common operating systems, they're general purpose operating systems which are great for a laptop or a desktop, but they include a lot of backwards compatibility, a lot of features that one particular application isn't going to use. Okay. And the principle of a unikernel is that you only take the elements that you need. Okay. Obviously, you're not going to run it directly on a laptop. You couldn't do anything, but we'll see domains where they are useful. So basically, on this continuum, going from monolithic applications running on bare metal hardware to VMs to containers, and now unikernels provide us another option, but they're not necessarily a panacea. We see there are problems. So if we look at what domains we might use them in, well, obviously in cloud computing, they're small, immutable entities. They boot quite quickly, and they provide the possibility of having on-demand servers, just-in-time creation of unikernels. Also in network function virtualization, so the same interest as the cloud. NFV is basically cloud for telcos, but with stricter requirements on response times and so on. And Ericsson Research have published information about a proof of concept they did in the NFV domain. I have just an image of that I'll show in a moment. Another area is IoT or embedded, where we can have low resource applications deployed out there in a very distributed fashion. While they might be bare metal, that's probably not going to be that practical. So these will probably be running on very low footprint hypervisors. And the approach is to then build up the application rather building on some generic OS that you try and strip down. Similarly, for high-performance computing, because there's potential for much better performance, on the other hand, it is trickier to work with unikernel, so at least short-term, it'll be harder work. This is just a I mentioned the Ericsson case of NFV. This is one scenario that they had worked on where running on a Xen hypervisor, they have one unikernel here, which includes the TCP/IP stack, and then a series of virtualized network functions, DHCP, NAT, and firewall, which do not deal directly with TCP/IP. They communicate via this vChan. And that example was written using Mirage OS, which is all written in OCaml. Okay. So I said that there are maybe 15, 20 implementations. There are two main families. So there's the clean slate approach, where typically the whole library OS is written in one functional language. And it's quite a purist approach, but that is really what unikernels are about. And then there are other legacy approaches, which tend to go for backwards compatibility, POSIX compatibility. Some of these are capable of running a static binary. Others will integrate either a GVM or even Node.js. So we're getting away from the minimalist approach of the clean slate systems. I'm not going to go through this list. I would say that almost all the unikernel implementations I know of are open source. One exception is actually Drawbridge, a Microsoft project, which there's very little information about it. There's certainly some announces about 8-9 years ago and a bit more recently. I expect it is actually used in Hyper-V and Windows Server 2016, or at least components of that technology. I just wanted to point out ClickOS is one from NEC Labs, where they're embedding unikernel into their networking hardware, into routers and firewalls and so on. That's a very practical application of unikernels. So I talked very briefly about Mirage OS. So Unikernel Systems, the company that Docker bought, they are deeply involved in Mirage OS. I'm not quite sure between University of Cambridge, Xen Project, Mirage OS, Docker, who is paid by whom, who works on what, but they're certainly working on Mirage OS. That said, the cool hack that they did at DockerCon, it's interesting to see that they used another unikernel technology. They used a rump kernel. So there seems to be a lot of collaboration amongst the different unikernel projects. But anyway, Mirage OS is written in OCaml, and that means that the unikernel base, or the library OS components, are themselves written in OCaml, which is a functional language derived from ML. So that leaves possibilities of performing proofs on some parts of the code. Okay. So Mirage OS provides a tool, Mirage, of course, which allows to build unikernels for different backends. Generally today, the two backends that are used are either Xen or Unix, so it can produce static binaries that you can run on a Linux or Mac OS laptop. They do also have a browser backend that uses conversion to JavaScript, but I don't know of any practical use of that one. Mirage OS 3 will be coming out this year. They're preparing a first beta of that, and that is integrating an IBM project called Solo 5. Solo 5 is adding a unikernel base backend that will communicate with KVM. Okay, so going forward, Mirage OS will run either over Xen or over KVM. IBM also have implemented this UKVM, which is a sort of reduced version of KVM specifically for unikernels. Okay, someone also did a prototype bare metal backend for Raspberry Pi. That's not in the main branch. So just say building for Mirage OS. Basically, you configure for the backend you want, Unix or Zen. You do a make, and you have a small executable. Just a hello world example is, I think it was 2.5 megabytes for the Unix and 4.5 megabytes for the Zen image. Some examples of the use of Mirage OS. There's the Pinata. This is a unikernel which is online. You can reach it at this address. This is basically a small application that contains 10, I believe it's now 14 bitcoins, and you're invited to attack it. I think it's been up for about 5 years, so there have been about 100,000 targeted attacks. In theory, the best they've achieved is denial of service. That said, there might be people who are more interested in breaking security other than to recuperate the 10 or 14 bitcoins. So it's not a proof of the security, but a good example. There's this example, Paygarten, who are preparing to deploy Mirage OS for their some sort of payment, obviously, credit card system they have. They'd initially tried to run these as AMI images, but found that too painful. Now with Solo 5, they're able to do that under KVN on Google Compute Engine. Okay, there's some tooling which is starting to be developed. So EMC Dell, and this is basically the Cloud Foundry, Spring Boot people. They've been working on a sort of common front end for different unikernels that exist. So here are some rumprun OSV. OSV, I didn't mention specifically. OSV can actually run the JVM, which, well, is moving a bit away from the purest unikernel concept, but you have choice. I've already mentioned IBM's Solo 5 project, which is being integrated into Mirage OS and the UKVM. OSV also has a Capstan utility for building. Both Unic and Capstan also have some sort of image hub behind them. Okay, I mentioned the idea of just-in-time. So there is a unikernel called Jitsu for Mirage OS, which can then be used as a DNS server, which will launch on demand a backend unikernel. And that's been tested with Mirage OS and rumprun. But I think what's more interesting is unikernels and containers. Why did Docker buy unikernel systems? So you should know that already these people are actively involved in Mirage OS, one of the main unikernel projects. Unikernels are already used as functions with the implementation of Docker for Mac. But what's more interesting is what's going to come, and I think it's a no-brainer that we can expect that Docker will make the build, ship, and run of unikernels simpler. So we're running out of time. I'll move quickly on that. And I think we can expect secure container deployments, which are basically hybrid, maybe having unikernels. They have some front-end functions such as the TLS tunnel. And I'm sure that when DockerCon, either US or Europe, comes around, I'm sure Docker will have some surprises for us this year. So I wanted to do a demo. I'm running out of time, so I'll be quick. So I just wanted to go to this site, Defi Panic. So this is basically a YAS. It's in beta, and they allow you to run some unikernels. So here's one I created earlier. I'll actually, so here in the dashboard of images, I have no images. I'm going to create one. So you can't really see this, but up here, I selected a rumprun unikernel. In fact, in this menu currently, we have rumprun OSV or include OS. And then I should have selected the language. There's a selection of Go, PHP, Node.js. Okay. Maybe that did succeed. Okay. Okay. In the interest of time, I'm going to move on to another demo. But just know that basically this Defi Panic, you can create an account and experiment with unikernels on their site. I've just a very quick example here. So of runtime.js, so this is one that integrates Node.js. Basically, this is a very small Node.js program with a bit of HTML here, and then just some JavaScript to show an alert. Okay, we can see that we have a 1.6 megabyte unikernel, and if I do npm start, boot launch commute, if I go back to my browser quickly, okay, so I get the JavaScript pop-up and then the HTML. There's also this guy here, based around his talk, Mirage OS. He put together a Vagrant package with 4 different unikernel demos. That's worth a look. So, my conclusions, I mean, it's the Wild West. There are still 10 to 20 unikernel implementations, and some of them are moving quite rapidly. But a lot of work needs to be done to make them easier to build and deploy and debug. Okay, debugging is possible, but it will be more like debugging an embedded application rather than a standard application. I'm pretty sure we'll see easier to use solutions. I'm sure Docker are going to help a lot here. The Solo 5 project from IBM will help, and also Unique from EMC Dell. And I think we'll start to see some synergies between the different unikernel projects. I know the HAL VM, which is based on Haskell, I know they're considering going with the rump run, maybe for the next release. They're an interesting complementary technology to containers, and I think we'll see hybrid solutions. This won't be the solution for all cloud. And I believe that 2017 will be an interesting year for unikernels. Between the various Docker cons, the release of Mirage OS version 3, and some services that start to come online, at least in proof of concept. I have a list of resources there, but that's it. Out of time. Perfect. So, questions?
Can you please go back to the slides before that? I can take a picture of the
Sorry, which one?
next one, previous one, with the GitHub links.
Okay. I'll tweet with a link to my slides. Yeah.
I have a very general question. Like, imagine we all embrace unikernels, and then we'll start running our apps as unikernels. But then we'll need tooling for, especially like for debug. Our app is running slow, so we need perf on Linux. Oh, how do I run perf on Zen? I can't. So I'll have to put like counters in my hypervisor. Wouldn't we end up like re-implementing the whole operating system we have, just like in a hypervisor? Maybe we should just use existing hardware features in the existing operating system to separate applications.
So, I think for some, flames are starting. No, it's a common question. On the one hand, you'll be able to do functional debugging, like with Mirage, you can build to a Unix backend. But obviously, yeah, if you want to test performance, then you need real debugging tools. And yeah, there will be need for tooling for that. I don't know, to answer more precisely your question. There will always be trade-offs between these things. But I'm sure that some tooling will come. It won't be as elaborate as on general purpose OSs, but there will be some. Yeah.
There's some option for external configurations. I understand that the configuration is actually compiled in.
Yes, that's right. Okay, so the question is there some way of having configuration externally? Because, yeah, I didn't labor the point. With an unikernel application, you actually compile the configuration into the unikernel itself. Short answer is I don't know. I'm sure, yes, that there must be ways, but I'm not sure what mechanisms you would use for that. And again, it comes down to usability. It's something that isn't very nice to have. Yeah.
What about security updates of the OS parts?
Yeah. Well, if you're running over an hypervisor, I mean, you'll have to manage that. Maybe Docker will have a solution for us there. So. Yep.
Is there an easy way to run a Python app that utilizes multiprocessing, that allows you use multiple virtual CPUs or real CPUs? And which stack would you recommend for that?
Okay, so the rump kernels, so rump run in particular, is the way, the question was, is the way for to be able to run Python apps on multiple CPUs and so on. So rump run is, I think, the best option to run Python, first of all, but that doesn't answer your question about multiple CPUs. I guess you would, I'm not sure what the best answer is, but you probably have to split your application up into several unikernels, which sounds tricky.
So microservices.
Yeah, definitely. So microservices, sorry, let me repeat the answer. Okay, I've had enough signals, I'll stop.